everyone. So this week, 10.5, we're actually going to learn how to graph the trig functions that we've been working with so far. So we've been talking a lot about sine and cosine, and this week we're going to learn what their graphs look like if we plotted their values on the x and y plane. So first of all, I just want to give a little bit of background information. I don't want to overwhelm you guys with stuff, but sine and cosine are what are called periodic functions. And so periodic functions basically mean that they're functions that repeat. Functions that repeat. And that's a really basic definition, but like I said, I just don't want to overwhelm you guys with a bunch of stuff this week. So periodic functions are functions that repeat the pattern, repeat a pattern. So sine and cosines look like wave functions, and they're going to repeat infinitely. So periodic functions, we're going to talk about just sine and cosine in Algebra 2. And so starting today, we're going to start defining some of their properties. So to graph sine and cosine, we're actually going to use the unit circle. So I have this little baby unit circle over here for the values. So if you notice, the axes are labeled pi over 2, pi, 3 pi over 2 to 2 pi, and in the negative direction. So we're going to find out, what are the sine values at pi over 2, pi, 3 pi over 2, and 2 pi. Well, luckily, hopefully, I don't know if you guys have your unit circles memorized yet or not. But, here's 0, pi over 2, pi, 3 pi over 2, and then all the way around the circle is 2 pi. So the coordinates, I have them labeled, 0 and 2 pi, it's 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And they're printed. Mine just isn't printed too well. So remember, a coordinate is cosine sine. So your sine value at 1 and at 2 pi, so sine of 0 would be 0. Sine of pi over 2, well, what's the sine value? It's 1. Sine at pi, the y value is 0. Sine of 3 pi over 2, well, the y value is negative 1. And then at 2 pi, sine of 2 pi would be, same spot, 0. And so literally all we're going to do is we're going to plot those. So at 0, sine of 0 is 0. So our first point is on the origin, and we have 0, 0. Your next point, sine of pi over 2, I just have these labeled. These are the nicest points. Pi over 2 is 1, and I'm going to call this 1. So I left these blank intentionally, so I'm going to label these negative 1 to 1. And that way, just so you guys can see better what the graph looks like. So pi over 2, 1. At pi, sine of pi is 0. Sine at 3 pi over 2 is negative 1. And then sine at 2 pi is 0. And so there's all these dots, and we're literally actually just going to, let's see how I do with this. We're literally just going to connect the dots in a nice wave-looking fashion. That's pretty good. All right, so this is what sine looks like. And this is once around the circle. And so this is what's called one cycle of sine. So one cycle is one wave pattern. So sine starts at 0, goes up, back to 0, goes down, back to 0. And if you kept going, it would keep going. It would keep going forever. And then it works the same way in the negative direction. So if we started at 0 and worked backwards, right, this is negative pi over 2. So sine of negative pi over 2 would be negative 1. So negative pi over 2 is negative 1. Sine of negative pi, if we kept going, would be 0. Sine at negative 3 pi over 2 would be 1. And then all the way back, negative 2 pi would be 0. And you don't have to do all this work every time. I'm just showing you guys where these points come from. But as you can see, it repeats itself. Yeah. So this represents like one positive rotation around the unit circle. And so this is called one cycle. So from here to here, so this, I'm just going to kind of outline it. This is one cycle of sine. And this is like the parent function. This is the most basic, the most basic function. And so from here to here is one cycle, and that's just because it does like one positive hill, and so I call these hills and valleys. So there's one hill and one valley. And so this would be another cycle of sine, one hill, one valley. So as long as there's one hill and one valley, that's one cycle of sine. And what it does is that's one walk about the unit circle. So from 0 to 2 pi, that's one walk around the unit circle. And in the negative direction, from 0 to negative 2 pi, that's one walk around the unit circle in the opposite direction. And so one cycle of sine looks like that, and that is the same thing as one rotation around the unit circle. And looking at the sine values. So cosine is similar, except now instead of looking at the sine values, you're looking at the cosine values. So you're looking at the x's. So, this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so we've got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So now we're looking at the x values. So cosine of 0, the x value is 1. Cosine of pi over 2, the x value is 0. Cosine of pi, the x value is negative 1. And then cosine of 3 pi over 2 is 0. So we're going to plot those now. So this one's a little bit different. So once again, I'm going to call this 1 and negative 1. You can go as many boxes as you want. Just label them. So cosine at 0, so when your x value is 0, the output is 1. So cosine looks a little bit different. So it starts not at the origin, but up here at 1. Cosine of pi over 2 is 0. Cosine at pi is negative 1. Cosine at 3 pi over 2 is 0. And cosine at 2 pi, oh, I didn't do that one. Cosine at 2 pi over here, x value is 1. So then 2 pi is 1. So cosine looks like this, and it's very similar in shape. So what a cosine rotation is it looks very much like this one, right? Except it has like a half of a peak, a whole valley, and then the other half of the peak. So really what it is it's kind of like if a sine graph was like shifted to the left a little bit. So if we took this and we shifted it like to the left, as if we started right here and ended right here. So that's the cosine graph. So it's just shifted a little bit. So if we kept going, it would look like up here. It's just been shifted. So if we go in the negative direction, so cosine at negative pi over 2 will be 0. And cosine at negative pi would be negative 1. Cosine at negative 3 pi over 2 would be 0. And then cosine at negative 2 pi would be 1. So then you get that same looking shape. It's supposed to be a nice curvy wave. All right, so it's a little bit different. One cycle of cosine looks like this. So this is one cycle of cosine. So again, that's one rotation around the unit circle. So one sine cycle versus one cosine cycle. So graphing sine and cosine are going to be slightly different because they have different common points. So I call these like there's 5 common points that we're going to talk about. And so for cosine, we've got 3 x-axis units, and then one high, one low. But cosine starts high. So cosine starts high, the midpoint is low, and ends high. So sine starts and ends at 0. Cosine starts and ends at a high or low point. High or low point. And it just depends on, we're going to talk about positives, negatives, that kind of stuff. But sine starts at 0, ends at 0. Cosine, in this case, it starts high and ends high. It's also possible we're going to talk about it's going to start low and end low. Yeah, so we're going to talk about how to graph these two different things. There's some common information that we're going to talk about in terms of properties. Hopefully I have enough colors. Let's see. So the first thing that we're going to talk about is the amplitude. And actually, before I do that, I'm going to label some functions for you guys. So the general functions for sine and cosine that we're going to talk about are f of x equals a sine b of x, and f of x equals a cosine b of x. So these are our two parent functions. And so we're going to put numbers here and inside the input. And so we're going to talk about what those two things do. And that's my secrets here. It's amplitude and period. So amplitude, this is probably something that you guys talked about in physics. If you've taken physics, amplitude of a wave is how big a wave is. And so hopefully we can see that we have waves here, whether it's a sine one or a cosine one. They're just shifted a little bit. But their amplitude is based about from the midline of your function. And for now, your midline is at 0. So here's the midlines of your functions. And that just means that your peaks and your valleys are equidistant from this midline. So right now, the peak and the valley are the same distance. And so that means your midline right now is 0. And so the amplitude is the distance from a peak or a valley to the x-axis or to the midline. So your amplitude right now is absolute value. So amplitude is just measuring like how big something is. So we're not taking negatives into account. So amplitude, for example, from here to here, from 0 to 1. So right now our amplitude, I'm just going to say amp, is 1. And same thing here. If we measure from here to here, your amplitude is 1. And same thing for the valleys, right? So if I measured from here to here, our distance, so distance, we take the absolute value of it. It's technically 0 to -1, but the amplitude is considered to always be positive because you're just measuring like how big it is. And same thing here. So your amplitude distance should always be the same for the peaks and the valleys, and it's always positive. So it's a positive value. So amplitude is the height of a wave. Height of a wave from midline to a max or a min point. And we consider amplitude to be positive. And it's the A value out front. The A value. So whatever number is out front tells you how tall your wave is going to be. So the A value, if you have an A value of like 3 out front, then it would be from 0 to 3 would be the height of your wave. Right now, if you check it out, sine technically is there, sine or cosine, technically what number is out front? If there's nothing out front, then technically it's a 1. And so that's why our amplitudes are a 1. All right. Next up is this thing called the period. And so the period has to do with the cycle. So this is the length of one cycle. And so a period is the length of one cycle in terms of horizontal distance. So how long did it take for the sine graph to complete one cycle? The period was from 0 to 2 pi. And so the period here is 2 pi. It takes 0 to 2 pi distance to complete one cycle. And same thing with cosine. From, here's one cycle in pink. How long did it take? Well, it started at 0 and it went to 2 pi. So the period again here, period is 2 pi. So cycle and period go hand in hand. So cycle is just saying like here's one peak, one valley. Cosine is half peak, whole valley, half peak. And how long does it take for that to happen? Both of the parent functions here, it's a period of 2 pi because that's how long it takes for you to walk around one normal unit circle. It's from 0 to 2 pi. So what we're going to do is we're going to explore some of these as transformation rules. So these are the parent functions where everything is just, a base. And so we're going to throw some a values out front. And the a value, if you guys remember, the number out front is what stretches it or compresses it. So that's why this is the dilations section of the units. So numbers out front are the stretches or compressions. And then the b value inside is the stretches or compressions in terms of the, so stretches or compressions outside affects the y distance. Stretches or compressions on the inside affects the x distance. So that's what we're going to talk about. So period actually has a formula because we're working in radians. So to find the period of a function is 2 pi over b. So the b value helps find period. And so one of the most common mistakes in Algebra 2 is that people just say that the period is the b value. No, it's 2 pi over the b value. So there you have to do a little bit of math to figure out how long one cycle takes. All right, so this is the general information about sine and cosine graphs. So this week we're just going to concentrate on amplitude and period. And so I'm going to teach you guys some tricks on how to graph these. And normally in class we do this together and it's really like hands-on. So I'm going to do my best to explain how to plot these and then we're going to practice. And I have a bunch of problems to practice with you guys. All right, so sine and cosine have different processes. So if you see a sine function, you're going to use this process. If you see a cosine function, it's this process. And so the first thing I want to talk about is, I need to scratch this paper. Real quick, we're also going to be throwing reflections in. So think about, and just out front. So if you have a negative out front of a function, so negative sine and negative cosine. So a negative creates a reflection. So sine normally looks like, sure. And cosine normally looks like it starts high, goes low, and then high. I didn't do a super good job, but sure. But if you throw a negative out front, that just flips it. So that means it's going to start low. Like you start at 0 and do the valley, then the peak. And negative cosine is going to start low, high, midpoint, and low. So hopefully we're okay with reflections. Just flip it. It looks a little bit weirder for trig functions, but literally if you take it like, your peak becomes a valley, and then your valley becomes a peak. And the same thing over here, like your half peak becomes a half valley, and then the valley becomes a peak, and then your half peak becomes a half valley. So generally they always have this shape, and there's 5 points that we rely on to make these. But some of the first questions you have to ask yourself are, is it sine or cosine, and then is it positive or is it negative? Because then that's going to affect the process. But we always plot the same 5 points. They're just a little bit different for cosine and sine. I try to make the process as easy as possible for you guys. All right. So sine, because sine starts at 0 and ends at 0, those are the first 2 points that I plot. So I plot these 2 first. So for sine, your first step is to plot a point on the origin. For now, it's always going to be at the origin. And period value. That'll be your last point of the cycle. So the first thing you're going to do is you're going to plot and period value, I guess, on x-axis. And these both live on the x-axis because they're 0. So our period for just sine is 2 pi. So, you put a dot on 0, 0, and then you know that your cycle is going to be done at 2 pi and it's going to end on 0. So sine starts at 0 and ends on 0. And then the next thing I do is I know that the midpoint, so halfway between the sine function, is also at 0. So then depending on, so our period's going to change because I'm going to give us some harder functions. But all you have to do is do, the period value divided by 2. So your second point is the midpoint. So plot point halfway. So period divided by 2. And again, that's on the x-axis. Because the starting point, the ending point, and the midpoint for sine. So starting point, end point, and midpoint are all on 0. And then now we have to stop and ask ourselves, is sine positive or negative? So if it's positive, it's going to look like it's going to go up, then down for positive. And if it's negative, it's going to go down, then up. So you need to ask yourself which case you're in. So if it's positive, you find the midpoint and then go high, then mid, go low. And if it's negative, it's the opposite. You find the midpoint, go low, and then you find the midpoint and go high. And what I mean by that is, so we know this midpoint, that's sine, that's cosine. So we know this, this, and this. So then for this first section, find that midpoint and go high if it's positive, go low if it's negative. And then for the second section, find that midpoint, go high if it's negative, go low if it's positive. And then you should be able to have your 5 points, and they should sketch nicely. And if it's negative, it will go the other way. All right, this sounds really confusing. So that's step 3. But I promise you, if you follow this process, it's going to graph pretty nicely, and we're going to do a bunch of examples with this process. Now, cosine is really similar. It's just because it starts in a different spot that I use a different process for plotting, or at least just explaining to you guys what to do. So cosine, actually, the first question is it positive or negative? Because if it's positive, it starts high and ends high. If it's negative, it starts low and ends low. And so cosine always starts on the amplitude value. Starts on amplitude value. So you'll figure out what that a value is, and you'll either start high with that a value or start low with that a value, depending on positive or negative. All right, and then step 2, the midpoint will be either the high point or the low point. So if it's positive, it's a low point. And if it's negative, it's the high point. So if it's positive, then you're going to find the low point, this one. And if it's negative, you're going to find the high point, this one. And it's all based on amplitude. And then the last step is the midpoints of those. They are 0. So they live on the x-axis. So like I said, so cosine here is positive. So our parent function is positive. So if it's positive, it starts high and ends high. So your cycle starts high and ends high. And it's the a value. So technically our a value is 1 because there's nothing up front. So it starts on 1 and ends on 1. So I plot those first. So the first thing you do is you start, starts high, ends high with the period value based on period. Based on period. So you're going to find the period and you're going to plot the first point and the last point. So it starts high, ends high. And then next up, you're going to find the midpoint. And the midpoint is a low point if it was positive. So you have your high value, and then in the middle should be your lowest value. And then it's the opposite if it's negative. And then the last 2 points, the midpoints of those are your zeros. So if you look, halfway between -1 and 1, it lives on 0. And then halfway between -1 and 1, it lives on 0. So this is probably pretty confusing. Graphing sine and cosine is something that I usually take a long time in class to explain all this stuff and explain how to plot points. So if you're struggling with this, that is a-okay. We're going to spend another week on it. Hopefully doing some examples next here is going to help. So I've got my notes, and I'm going to leave these up here so I can access them. So the first thing that I do for all these problems, and my graphs did not print well at all because my printer is terrible, so I'm sorry. So the first thing I do for all these problems is I label amplitude and period. And so if it's positive or negative, right? So this is sine. So sine starts at 0, ends at 0. So those are your first and last 2 points. The amplitude, I abbreviate with amp, is the number out front, is your A value. So it's 3. And then your period is 2 pi over B. Your B value is 4. So the period is 2 pi over 4. 2 pi over 4 reduces down to pi over 2. So that means that we're going to complete a whole graph here. Oh, this one's super skinny. And pi over 2. So the period is pi over 2. So we're going to complete a cycle in pi over 2. So it's going to take a pi over 2 to complete one cycle, which is kind of crazy because it's right there. So it's going to be really skinny. So let's go back and reflect on the process. So I have a sine function. It's positive. So that means I'm going to start. So you plot a point on the origin because it's sine. So I start at 0, 0. And then my last point is your period value, so pi over 2. So I'm going to have one whole cycle between here and here. So it's going to be really skinny. Next up, plot a point halfway through the period. And a lot of times you guys don't really have to divide by 2. Like you can just see like what's halfway between 0 and pi over 2. It's pi over 4. So I mean, that's my third point. And then that's where you need to ask yourself now, is it positive or negative? Well, it's positive, so that means it's going to go up and then down. So you're going to have a peak, then a valley. But you need to ask yourself, how far should I peak to? Well, the amplitude is 3. So that means your wave height needs to be 3 in the positive and the negative direction. And so you go halfway. So go mid and then go high up to 3. So that looks like the halfway point. And then for the second one, go mid and then go to the amplitude, which will be 3. And so this one it's really skinny. So this is one sine curve. And so this is one cycle that's been completed in pi over 2, and that's all there is to it. So just to reflect, sine, your first points that you plot, 0, 0, and then your period. And then halfway is also at 0. And then all you have to ask yourself is if it's positive, it's going to go up, then down. And then you just have to figure out how high up does it go. Well, the amplitude's 3, so I'm going to go up to 3, down to -3, and you're done. And then if you guys want, you don't have to. This is an acceptable answer. This is all I'm looking for from you guys. But if you want, you can keep it going. There's going to be dots on every. So then it's going to go up and then down. It doesn't help that I don't have grid lines, so this is really hard for me. So this is going to continue. It's getting messier as I go, but. So anyways, yeah, it's going to look like that. It's going to keep going forever, and it goes in the negative direction as well. So, yeah. So hopefully graphing your first sine graph's going okay. All right, let's graph a cosine graph. So again, it's the same process. It just looks a little bit different because the points are in different spots. So cosine. So you're going to find the same things. The amplitude, in this case, is 5. Your A value is 5. And then the period is 2 pi over B. Well, your B value in this case is 1/5. So you've got some fractions, so keep it, change it, flip it. So that means it's 2 pi times 5 over 1. And so 2 pi times 5 is 10 pi. So you're going to complete one cycle in 10 pi. So that one's really big. So we have like two extremes here. This one's really small, this one's really big. All right, so, and And cosine is positive. It's a positive cosine. That's good to know. All right. So now our first question is it positive or negative? So it's positive. So positive means it starts high and ends high. So we're going to plot the 2 period points. So we're going to start on the y-axis. So it starts high, and our height is 5 because it's the amplitude. So it starts high at 5, and it's going to end high at 5. And it ends at 10 pi because it's 1 period. So here's 10 pi. Oh, my grid lines are so bad. So it starts high and ends high. So it starts at 5, ends at 5, from 0 to 10 pi. So I have 2 points, 3 to go. Next up is you find the midpoint. If it's positive, it's going to be your low. If it was negative, it would be the high point. We're in the positive case, so it's going to be our low point. So we're going to go down -5. We have to find our halfway first. So halfway between 0 and 10 is 5. So here's 5, and we're going to go down -5 because the amplitude's 5. So here's my high points, here's my low points, and then your midpoints of those are the zeros. So halfway between 0 and 5 is 2.5. And then halfway between 5 and 10 is 7.5. And that's it. Now it looks like a V, right? But remember, it's a wave. So, you know, cosine, like, so here's like your half peak, your valley, and your other half peak. And then, as I said, you know, you could keep going. All I'm looking for, though, is for you guys to draw 1 cycle in for me. All I need is these points. You don't have to keep going. This is great. But I just want you guys to know, like, it does, you know, keeps going. All right. If you guys would like, I would probably pause and try these 2 on your own. These 2 have the negatives, and I want to teach these ones. But if you want to pause and try these 2 on your own, I think right now will be a good time. Because I've done 1 sine and 1 cosine with you. So if you guys want to try doing a sine and cosine by yourselves. And then we're going to talk about negatives. All right, so let's graph cosine of 2x. So amplitude, what number is technically out front? What's your a value? If there's nothing, it's 1. And then your period is 2 pi over b. My b value is 2, because that's what's in front of the x here. So your period is 2 pi over 2, and it cancels out, so it's just pi. All right, so we're going to complete 1 cycle in a length of pi. So we start at 0, go to pi. Pi is right here. And it's cosine, and it's positive. So it's positive cosine. So let's go look at our positive cosine rules. So it's positive, starts high, ends high, and your amplitude is 1. So it's going to start, so this one's going to be kind of short. So it's going to start at 1, and at pi, it's going to end at 1. So then your next point is your midpoint, and it's a positive, so it's going to be our lowest point. Halfway between 0 and pi is pi over 2. And like I said, you guys, you'll have the graph, so you can just visualize as well. Halfway between 0 and pi is pi over 2, and it's going to be our low point. So our amplitude's 1. So that means if our high point is 1, our low point is -1. And then the midpoints in between those, so in this case, halfway between 0 and 2 pi is pi over 4. Pi over 2 and pi is 3 pi over 4 are your zeros. And then you just connect it and make a cosine cycle. Ta-da! And like I said, you guys can just stop here, or if you want, you know, you can keep going. It's going to look like it's going to look like that, you know, if you keep going. All right, sine. All right, it's positive. The amplitude is your a value out front, so it's 2. The period is 2 pi over b. Your b value is 1/3. So again, keep it, change it, flip it. That means it's 2 pi times 3 over 1. So it's 6 pi. So you're going to complete 1 cycle in 6 pi. All right, so it's a sine graph, and it's positive, so we're going to go to our sine rules. So plot a point on the origin, 0, 0, and at your period. And our period is 6 pi, so here's 6 pi. So remember, sine starts at 0 and ends at 0. All right, so halfway between, so now we're going to plot the point halfway, your period divided by 2. So 6 divided by 2 is 3. So we plot another 0 at 3. And then it's positive, so it's going to peak, and then it's going to valley. So halfway between 0 and 3 is 1.5. And at 1.5, what's our amplitude? Our amplitude is 2. So at 1.5, we're going to go up to 2. And halfway between 3 and 6 is 4.5, so we're going to go down to -2 to make a valley. And you connect the dots. Ta-da! And like I said, you know, all I'm looking for is this, but if you wanted to, you could keep going, you know. All right. And now lastly, I'm going to finally talk about some negative ones. All right, so technically, right, the negative here is a reflection. You guys have done plenty of transformation labeling. So that's a reflection. This is your vertical stretch. So, and your vertical stretch represents your amplitude, because that's how much you're stretching it, right? Like you guys can see here, your vertical stretch was 3, so it's really skinny and it's tall. Here the vertical stretch was 1, you know, so it's just standard, and so that doesn't look really skinny. Here you've got a vertical stretch of 3, so your amplitude is 3, but that negative means we're going to go the other direction. It's been flipped. Your period is 2 pi over b. Well, your b value, if there's nothing here, b is 1. If there's nothing in front of x, your b value is 1. So 2 pi over 1 is just 2 pi. And so that's the length of your cycle. All right, so, all right, it's a sine graph. And so the start to the sine graph rules, you don't need to know if it's positive or negative yet, right? Because your first 3 points are on the x-axis. So plot a point at 0, 0. And then your period. Our period is 2 pi. This one is kind of, so the graphs are a little bit different. I generated these and stole the graphs. And in theory, the graphs are supposed to be like somewhat to scale for the problem. But anyways, so they're all a little bit different. So your first point, 0, 0. And then your last point is on your x-axis at the period. And the period is 2 pi. All right, and then the halfway point. So next I plot the halfway point. So halfway between 0 and 2 pi is pi. And then you find the halfway points of those and plot. But now it's the question of, is it positive or negative? Well, this one is negative. So if it's negative, you're going to go valley, then peak. So halfway between 0 and pi is pi over 2. And our amplitude is 3, so I'm going to go down 3. And then halfway between pi and 2 pi is 3 pi over 2, and we're going to go up to 3. And then you sketch your curve. And so if you guys notice, that's the opposite. It's been flipped. So normally sine would have the peak, then the valley, but because of the negative reflection, it's the valley, then the peak. All right, and the last one, a negative cosine. So it's negative. The a value, the amplitude, well, it's just negative, right? So the trick here, you guys, is the amplitude is not -1. The amplitude is 1, right? This is the reflection. And the number out front is 1. And so your vertical stretch value is 1. So the amplitude's 1. And then your period is 2 pi over the b value, which in this case is, it's the 1/2. It's a fraction, so keep it, change it, flip it. 2 pi times 2 over 1 is 4 pi. All right, so we're going to complete one cycle in 4 pi. All right, and this one's a cosine. So we're going to complete one cycle in 4 pi, and it's negative. So that's why the first question for cosine is it positive or negative? Well, it's negative, so it means it's going to start low and end low. It's going to start based on the amplitude value. And the amplitude value is 1. So we're going to start on -1 and end at 4 pi at -1. Now halfway between 0 and 4 pi is 2 pi, and your midpoint, that's going to be, because we're negative, that's our high point. So our high point is based on your amplitude. The amplitude is 1, so the high point is going to be at 1. And then halfway between 0 and 2 pi is pi. That's going to be your 0. Halfway between 2 pi and 4 pi is 3 pi. That's your 0. So here is your cosine curve. This one's kind of long and drawn out. And like I said, you could keep going. All right, and that's it. So, keys to successfully graphing: identify the amplitude and the period, and then just follow. It's the instructions are kind of like scary looking, like there's kind of a lot. But the trick is really it's just midpoints. And so sine, you guys, has 3 points at 0. So sine always has for initial, final, and midpoints at 0, and then it's either high, low, or low, high. Cosine starts using the amplitude, so cosines will start at 1 and end at 1, or start at -1, end at -1, and halfway is the high point, or halfway is a low point, and then halfway between those are the zeros. So once you start practicing and get the hang of it, it's not too bad. We're going to practice this more next week. So right now we've only added in the transformations that deal with, flipping it around the x-axis, stretches, and compressions in both directions. So hopefully this goes okay out there. The WAMAP, you only have to plot 2 points. So hopefully the homework can be helpful. And let me know if you guys have any questions.